Okay, guys and girls, we're looking at trying to represent the concept of energy storage. And at this point, we've already learned the different types of energy that we have, but now we want to represent how energy is stored and how we're going to represent that in a graphic way, in a visual way. So we're going to be looking at energy of pie charts and possibly looking at the concept of representing them in bar graphs. But for now, we're going to be kind of giving a quick example. And the analogy we have is this, and if you can read this along with me, the analogy of money is helpful to clarify the ideas of energy transfer and storage as opposed to different forms of energy. So the example that we're looking at is that money, can be stored in many ways. Some of you may put it in your wallet or put it in a bag, like a handbag, kind of a nice one, you don't want any, well, anyway. Some of you may have a checking account, or some of you may even, your parents have asked you to put money into particular things like certificates of deposits called CDs, or what's called an IRA, an individual retirement account. But again, it's all money. And the thing is that it's only one way that we store it. And again, we don't store money under our beds or in our dresser, and because we can lose that. But these are actually pretty secure ways that money can be stored, put in, taken out. So we're now going to be looking at the fact that all of these interactions in energy can be explained as storage modes, or what are called transfer mechanisms. So we want to look at the fact that there are different ways that energy can be stored and different ways that energy can be transferred in different ways from one form of energy to another. Now, from the different videos that we're going to be looking at, we want to talk about some of these energy modes, and we want to be able to define these and where you find the energy. So some of the explanations and some of the abbreviations that we're going to be using, we're going to be first using gravitational potential energy, which we'll be labeling as E, the little g, kinetic energy, which is E, the little k, elastic potential energy, that's energy where you're stretching a band or something along those lines, or a spring, and we're going to call that E with a little el, elo. And the last one is the fact that energy sometimes disappears, or sometimes, as the term goes here, it dissipates in the form of sound, light, or heat from friction. When things are moving, and because of the interaction with the ground surface, there's going to be energy that's dissipated. We're going to call this E-dis. So these are the particular things we're looking for. Now we're going to look at one example to kind of explain some of these forms of energy. So over here, we need to look at the fact that we have a system of a reaction, or a system of what's going to be happening. So again, we look at the particular situation here is we have a spring that's over here, and we have some kind of an object. Okay, so everything within this box here is going to be considered to be our system that we're going to analyze. Outside the system, it's going to be known as our surroundings. Okay, and the surroundings is just anything that is not directly part of the system. Now, some of the pictures we have here are representing a nanosecond of a system in motion. So this system has a spring and an object on top of it. So in this particular case, because we are using a spring, we are going to show that this is all what's known as elastic potential energy. Okay, we have here that it's EEL. And the way I'm going to represent EEL in this video and the rest of the video is I'm going to be using different colors. So since EELs are kind of icky, I'm going to use green. So the stored energy in the spring, in this case, it's all stored energy, the spring energy. So I'm going to represent all in green, 100%. Okay, 100% energy. Now, sometimes we have objects that will end up going up in the sky. Okay, and so we look at what is known as the energy stored due to gravity, based on its gravity due to the Earth. So we're going to be looking at this one is going to be representing gravitational potential energy, or known as EG. I'm going to be using blue to represent this in subsequent videos. Okay, so this is 100% because we're talking about the instance it stops moving. Okay, we see this. Velocity is equal to 0, so it goes up as high as it can go, and at the very instant it stops. Now, tell me a little bit about what you think that's going on here. Think about it for a few seconds. But what we do see is that the object is about half the distance. It's moving in this downward direction. So what do you think? Think about this for a little bit. And stop the video at this point to make your prediction of how this is going to be represented here. Okay, now that you made your prediction, I'm going to show you what's happening. So this is halfway. So with this blue energy, with this energy of gravitation, we see that it's halfway down, so it's half the distance. So we're actually just going to be coloring in this pie chart half with blue. Because blue, as I said, is representing our gravitational potential energy. Now we're introducing a new color, okay, which represents the fact that it's moving. And so the thing is that we're going to actually be using red for kinetic energy. Okay, because it's halfway the amount of energy that's being used. Okay, so again, just to wrap up some talking points. Okay, energy is represented in different storage modes, and we can represent that energy understanding the different forms of energy of gravitational potential, which is EG, kinetic energy, which is EK, elastic potential energy, which is EEL or EEL, and dissipated energy. Now in these systems we review that we're going to be using green for EEL, EG is going to be blue, and KE is going to be red. And if we look at our systems again, we see that first, that we can represent them as pie charts, okay? 100%, and in this case, we see that in this last example, it's 50% of gravitational potential energy and 50% kinetic energy, okay? So keep these certain things in mind. You can always come back to this video to check up as we go through some of the examples.